Hi dear students, today we are going to continue our lesson pages between 4 to 7, and the title is the earth of resources. And the resources that humans are using can be divided to the three main group: non-renewable resources, renewable resources, and potentially renewable resources. The first one, non-renewable resources, is those energy or those power that we are using in our daily life, which will be finished one day, like all fossil fuels, like oil, like petrol, like those things that are fossil fuels. And another one is a renewable resource. Renewable resource will not finish, like wind power or solar power and water power. I will show you some pictures next slide, and I will explain you more about these resources. And then this third one is potentially renewable resources. It depends on our behavior. It depends on humans' use. If human use it faster and more, so it will be finished. But these resources have a potentially to be renewable if human use slowly and in a reasonable use. Like fresh water, if we use too much or waste fresh water, so fresh water will be finished, and fresh air and biomass also. This slide shows you some example, and you can have a visualization of these resources. Non-renewable resource, as you can see, like fossil fuel can be obtained uh, from the earth or from the bottom of the sea or ocean. Then it can be used in lots of factories, which those factories are responsible for producing energy like electricity or like the things for our human life. And but there are many side effects. There are many pollution from these factories that make our earth like yeah make our earth polluted. Renewable resources like solar power or like wind power, as you can see in the middle here. So um, wind are not considered that we finish one day, or solar energy is not considered to be finished one day. They are constantly uh, can be used. And so yeah, these are renewable resources, are not they are not non-renewable, can be used more constantly. Potentially renewable resource, at the top left picture you can see that there are some factory or the places which they store the dead body animals or dead body plants. The waste plants or after farming, there are many left plants or the dead body of the plants. I mean, then they can be stored in the storage for a long time, and those waste material can produce ethanol or other chemicals. Those chemicals can be used for uh, for vehicle or factories, for burning and producing energy. And also fresh water, as I mentioned, fresh water like rivers, lake. So they are they they are depends on our attitudes. If we use rapidly, then it will be finished. But if we use reasonably, so we can save our resources. Also, human can use gases from air. I said that we have different type of gas in air, like CO2, carbon dioxide, and nitrogen, oxygen, argon, and other gases. And human can take these gases from air. But these gases, we need these gases from air. Actually, they are useful, and we can do many things. For carbon, or carbon dioxide, actually we don't take it from air because there is enough carbon resources in the earth, like fossil fuel. As I said, fossil fuel can produce lots of carbon based material, carbon based chemicals, like later we will study about the alkanes or alkanes. Those are contain lots of carbon, and then no need to spend energy or spend something to get carbon dioxide from air. But for nitrogen, as I said, nitrogen has the highest concentration of the gas in the air, so it can be taken from from the air, and then can be used for producing ammonia and fertilizer in a harbor process. And then those fertilizer and ammonia can be used for the farming, and for encouraging the plants to be grow, and for helping to plants. So another use is it's cryogenics, which this process is used in laboratories for storing living things in low temperature. By decreasing the temperature and using the nitrogen gas, also sometimes they decrease the temperature to make the nitrogen gas to liquid form. Then many living things can be stored for a while or maybe for a long time. And also the another use of nitrogen gas is to keep away products from reacting with oxygen. If you see that we have many things like chips, like many things in markets, even bread, some kind of breads or Coca-Cola, and many things that we can find in the markets, which they can be kept in for a long time. That means they kept in a nitrogen. They use the nitrogen gas or nitrogen liquid form to keep the products or nutrients for a long time, for longer time. And another useful gas is oxygen. Oxygen can be used for production of the steel from the cast iron, and this process is happen in the factories. And pure oxygen cylinders can be used for breathing in hospitals, and for patients which those patient needs to breathing artificially, uh, doctors or nurses use oxygen cylinders, which is obvious, and we all knows about that. And another one is argon and other noble gases. These type of gases are actually unreactive. And one example for use of this type of gas is lamp. If you look at the lab structure here, there is one tungsten filament. The tungsten is a type of element which can be used to make a light. Okay, these elements, tungsten, get a power from the electricity from actually entered gas. Not sorry here. Oh, here is not mentioned. It's actually here in the middle. The tungsten is joined to here this central part, and then get the electricity, get the power, and then the tungsten get heat. Okay, when tungsten get heat, then produce the light, but this light should be preserved from the oxygen. Okay, inside should not contain the oxygen, otherwise the oxygen react with the tungsten filament and then it explodes. So inside there is such a unreactive gas like argon. They fill this glass ball with argon to preserve the tungsten filament after the tungsten overheats. Okay, so this gas can protect the tungsten, heated tungsten, against the oxygen. This should be actually zero oxygen inside. So yeah, but how gases have used from air can be taken from the air? By fraction distillation. Fraction distillation is one process in factories that they get air first. As we know, air contains different type of gases, and after receiving air, it it get cool, okay, and get cool with high pressure, and get liquefied. Okay, it get liquefied, and then it transferred to another big container. Right, the container is fractionating column, as it's written here, because I took this picture from internet. Yeah, fractionating column. So there is a heater. Again, this cooled air, actually it's a liquid form, get heat again, but each gas has different boiling point. For example, argon get boil like minus 154 Celsius, and krypton also same, and oxygen get boiled at minus 183 Celsius. Argon get boiled after heating, I mean after heating, argon get boiled around 100 minus 186 Celsius, and nitrogen 100 minus 196 Celsius, meaning that nitrogen is the first gas which leave the container, with leave the column, because nitrogen has the lowest energy. After just a little bit heat, the nitrogen get boiled and become a gas. When it become the gas, then can leave the column from the top. Then imagine here we have a big amount of liquid. Then during the heating, the liquid can produce argon. Argon can get boiled. I mean, can become a boiled and leave the column after nitrogen, because the boiling point is minus 186, meaning after giving heat, argon can easily be be the gas form. So it leave the column after the nitrogen. Then it continue after the argon is oxygen, then krypton and xenon also. And krypton and xenon can be leave the column at the last as a last gas, because the boiling point is higher than the other, not the lowest. So in this way, we can separate each gas from the air. So that's all for today. Please leave a comment down as your attendance, and I will check your submission. Thank you so much. Take care.